Thank you, Heinrich. My name is Robert Terhaar. I'm going to be talking about delegated configuration with multiple Hiera databases. First, a little bit about myself. I work at a consulting company. We build custom cloud automation systems, deployment systems for a lot of different industries. Personally, I've been a sysadmin since 1998 and a Puppet user for a really long time also. We're based in New York City, and we've had a great opportunity to work with a lot of different companies on several really great projects. So, like I said, we're going to be talking about Hiera databases, delegated configuration with multiple Hiera databases. So first, before I really get started and really get into it, let me get a show of hands. Who is using Hiera today? Like everybody in the room. That's excellent. So I'm going to touch really quickly on what Hiera is. You probably already all know. This is my kind of definition of it. You may have different definitions. It's a system for organizing and also hierarchically organizing your data and pulling it out of your Puppet code. The whole goal is to externalize your data and move your data out of your Puppet code into a different system. And so let's first talk about what kind of things, like when we talk about data, what sort of things do we really mean? First of all, and most important, keep your secrets in Hiera. All of your SSL certificates, anything that you wouldn't want to check into your Git repository or source control. My personal favorite is eYAML, and it's really easy to get going. You should use that if you're not already using it. Store your business logic in Hiera, and what that means, I'm going to go into it a little bit more in a moment. Some people will put OS-specific things in Hiera, and it doesn't really work so well for that. You should store your OS-specific things in your params PP rather than in Hiera, because obviously Hiera is not params PP. So when I say business logic versus OS-specific configuration, some examples of that is in production, we use this database IP. In this data center, we use this NTP server. On RHEL 7, it's going to be the one when we finally turn on SE Linux, so we want to make sure that we're enforcing SE Linux. OS-specific configuration are things like different package names for different distributions. And also, it's not really an OS-specific thing, but just some sane defaults, like if we have one CPU, just use one worker. But if there's multiple CPUs, have additional workers. So those sorts of things. So again, you're already all Hiera users. So I'm going to give a really quick basic example. It's a function call, right? And so we use Hiera as a function, and we search for a key. And in this case, we have NTP as the primary namespace, and servers is the secondary key. So often this is used as a class parameter, right? And we in this case, with our fictitious NTP server, we're looking for servers that we're going to use for our NTP servers. There's an implicit lookup, and this is a newer thing in Puppet 3, where you don't actually have to have that Hiera function. Puppet will automatically run Hiera for all of those keys. And in this case, it'll look for NTP : servers, just because we have a class parameter called servers. And that's called implicit lookup, or the data bindings. And so that's basically how that works. You can also specify a secondary argument, and that will be the default. So if Hiera can't find something for NTP servers, it will just use the secondary thing. And that's, in this case, pool.ntp.org. So this is a really basic hiera.yaml for Puppet open source that goes under etc Puppet Hiera YAML. And for this example, I have a pretty basic hierarchy. You may have more tiers for your hierarchy or less. It's sort of different for every single environment. And in this configuration, I'm only using a single backend. I'm only using the YAML backend. And at the bottom, YAML has some specific configuration options for that. That's the datastore. That's where all the YAML files where they'll be stored. And so if we look at that etc Puppet hierarDB, this is what it would look like, right? So we have a lifecycle, we have location OS, and all of those folders map to our hierarchy. And this is where things start to get a little bit exciting because Hiera supports multiple storage backends. So there's a lot of different storage backends that are open source. Some are maintained by Puppet, some are maintained by community members. But writing a backend is very, very simple. And so a lot of them exist. And depending on what sort of database you like, you can pick one or multiple if you'd like. So an example of this, I'm sorry if the text is a little bit small, but I added a second backend. So I have the YAML backend up at the top, but then I also added a Postgres backend. And so Hiera will actually look at the YAML backend. It will traverse the hierarchy for all of the YAML files that match. When a node checks in, it will search all of those folders for things that match and pull keys out in the right hierarchy. And then when it's done doing that, it will search the Postgres backend additionally. So we can have a primary data store and then a secondary data store based on the order that we specify under the backends. At the bottom in this example, the Postgres backend has configuration for it. I didn't fill out the host and username and password and everything like that. The Postgres backend for Hiera has all of its own configuration. You can go read about it. It's pretty straightforward to get set up with it. I have a link at the end also. But that's, okay, so in this one, for example, after we've added the Postgres backend, there's a production.sql file in there. And this is a specific thing for the Postgres backend that we can put these .sql files with instructions on how to query that Postgres backend. However, I don't want to focus on the tools quite yet. I want to take a step back. Now that you're all Hiera experts, I think you already were when you came in, let's blow up that saw and let's talk first about design. So I'm going to be talking about Hiera. I'm also going to be talking about sort of like a case study for a system that we designed. So you can't really talk about design unless you have a Dieter Rams quote. And in this case, he has an entire essay, which I recommend reading sometime if you want to learn a little bit more about design. He didn't design that chair, but it looks like something he may have designed. But basically, if you enjoy Apple devices, Apple has sort of continued the spirit of the designer, Dieter Rams. And that is, good design is as little design as possible. I think Hiera really fits into this because I think it's really well designed, but it's also very simple. So design and architecture are kind of semantics. Martin Fowler defines architecture as far as like system architecture is the stuff that's hard to change. I think he said in this essay, architecture is the stuff that's hard to change later, and there should be as little of that stuff as possible. So architecture is the things that you're not going to change. You're going to keep using Puppet, right, because it's awesome. You're going to keep using Linux for your Puppet master. It's going to stay in PuppetDB. We're not going to replace our x86 servers with Spark servers. These are the things that are like architecture. But we should try to have as little of those things as possible. So to continue on with the semantical difference, architecture is like the concrete bricks, where design is like the replaceable modular Lego blocks. And if you can't see in the photo, this is the Frank Lloyd Wright's Falling Water as a Lego toy. And that's the same as the original picture. All right, so now that you're all experts on differences between architecture and design and Hiera, I'll start talking about the scenario. So we have nodes, right? And we start managing them with the Puppet master, and so then we have resources. We have all the Puppet stuff, everything that goes along with our Puppet master or multiple Puppet masters. PuppetDB, our environments, Hiera modules, manifests, templates, any other things. Let's focus on Hiera for this conversation. We have our hierarchy that we talked about before. FQDN lifecycle location. Yours will probably be different. This is a really basic hierarchy. However, the delegation piece comes in when we start talking about who's managing these components. For our scenario, we have the DevOps team, and whoever that may be manages these things and has full access to these things. But what about everyone else? What do we start doing to try to give access to some of these things to everyone else in a really controlled way? For example, let's say that we have people that aren't quite in the DevOps team yet, but we need to give them access to manage a few parameters. In this case, let's say we have Windows servers that we're managing with Puppet, and we want to be able to delegate NTP servers. And this is kind of it's a really simple example, but everyone understands NTP servers, and so I think it's a really good example of a key that we would want to delegate out to another team that maybe isn't quite up to speed on Puppet or committing source code or other things like that, or there's other access control issues. So delegation is kind of the key word. I'm going to keep talking about delegation. So basically, I define delegation as giving only a small part of access in a controlled way to a set of people. So we've reviewed Hiera. We're experts in Hiera. We've talked about design and architecture. We have a kind of a problem statement, kind of a problem area that we're going to dig a little bit deeper into. But before we can really get started, let's define what our problem statement really is. And during this talk, I'm going to be really focusing on the design process for how we're going to be designing this thing. Because maybe in your head, you're all engineers, you've already worked out well, I would do this or I would do this. But let's take a step back and let's not jump into a solution right away. Let's first walk through the design process a little bit. So an example of a problem statement right away is we need to delegate access to a few hierarchies. And I say, stop right there. Because this is a solution statement, this is not a problem statement. We've already solved the problem before we've even started defining what the problem is. This is too much focus on the tools. This is too much focus on the solution. So I think a better one is to have it be more people specific. In this case, colleagues who are not in the DevOps team need to manage a few predefined parameters, but only on a small subset of servers. And there's no tools here. There's no solutions here. We're just trying to understand the problem space that we're working in. So if you go back to this diagram earlier, we've defined our problem in one sentence. So from that, we can begin working out what we're going to be building. We're focusing on more about what we need to do under which context rather than how we're trying to solve it. So going on to step 2, we're going to start actually gathering requirements for solving this problem statement. If we define our requirements, we're essentially defining what success means. And if we can define what success means, it's a lot easier to succeed, right? And so you start by defining what success means by sort of gathering these requirements. For example, if you have a requirement that you must build a solution that flies, does that mean that you build yourself a 747? Or do you build an airplane, a paper airplane, right? Your solution, obviously, your requirements document does not really need to be over-engineered. It needs to be the specific amount of detail for your problem. As engineers, we tend to over-engineer things as engineers, always just in case we need to do some extra stuff. For our requirements document, we're going to start very basic. We're not going to over-engineer our solution, and we're not going to over-engineer our requirements document. Okay. There's a big article on requirements analysis on Wikipedia, and it's actually kind of cool because people, write really long books about this thing, but it's a good place to start thinking about building requirements. There's a lot of different requirements types. I'm not going to read them off to you, but we're going to focus on the very basic. They're called customer requirements. So if we were to start writing our requirements document, we would talk about what we're building, what are the basic goals for what we're building, and of course, while we're doing this, we're writing them down. And this is a proper document. It doesn't have to be long. It doesn't have to have company letterhead or anything like that. We need to define when this thing will actually be done. At what point will it be completed? And along the way, which assumptions are we making? And what are some risks while building this as well? So after we have this maybe first draft, we start getting some feedback. And again, we get feedback from people like your boss or the client, your colleagues, or other stakeholders. And it depends on your context. But once you have this requirements document, getting feedback on this requirements document is super powerful because it allows us to iterate on this document. And through the iteration process, it might be, if you're just doing this for the first time, or if you're not used to doing a requirements document and iterating on it, it might be kind of challenging because you're like, okay, I'm just going to have more stuff that I have to do and more stuff that I have to do. But if you do it right, it means you have to do less and less stuff. And that's kind of your goal, right? Like, you don't want to have to build stuff that you're assuming that you have to build. If you have a couple of conversations, maybe you have to build a lot less stuff and gives you a lot less work. Throughout the process, of course, own the document. Because maybe what might happen is that you go and show one of your colleagues, and your colleague is like, this is great. Tell you what, I'm going to take this over, and I'm going to go get feedback and things like that, and say, oh, okay, you can do that. But if you're the lead engineer on this, you need to continue to own the document and continue to iterate on this so you have a clear goal and vision about what you're doing. And of course, be realistic and prioritize through the process. This is from one of my favorite Simpsons episodes. Like, a car company hires Homer to design their everyman car. And throughout the design process, he wants all these really ridiculous things, but it's really only useful to him. And the car ends up costing like $1 million, and the car company goes out of business as a result. Because they weren't being realistic during collecting this design process. If you're not sure about things, just be vague. Because it's better to be vague than to overpromise. And that's okay if you're vague, but during the process, you will get a lot of feedback, and there might be some surprises during the feedback that you didn't initially expect. I gave this talk last week to some friends, and my one friend said, originally the slide said unexpected surprises, and my friend said, can you give me an example of an expected surprise? I'm like, yeah, I can't really give an example. So I went and changed it, feedback and surprises. So you get feedback, and you'll find some surprises along the way, most likely. In our case, the surprise was we started having these conversations, and another team had already been building a system to import data from a CMDB system into Hiera. And so the initial problem was delegation. As we started defining the system to how we were going to solve the delegation thing, the surprise that we found is like, okay, someone is building a system to import data from a CMDB, which already has a lot of this access control stuff built in. So with that surprise, we started writing the document. And this is actually a live video from my computer. I opened up my computer, and I started typing all this stuff out into Notepad. And so this was the question, what are we building? And so this is what we defined it as. We're building a data import system for Hiera, which allows secure delegated access to end users. The system filters data, and it can import data from various external systems. So this is really different from what we first set out to design. We came up with these goals for it, right? Import filter data from various sources to a database. The database is a secondary Hiera backend data store. Adding additional import sources should be simple, and that's a key one, and I'll review that with you quickly. And most importantly, it must be easy to understand where the keys are being imported from. Because as we add those additional sources, keys will be imported, and we don't know what's going where. So I went back to Notepad, and I made the window a little bigger because I have all this other stuff that I have to type. And we basically listed out our criteria for how we knew when the first iteration of the system was going to be done. We're going to build a prototype. We're going to document the solution. Again, it doesn't have to be overkill. It can be like 2 different Notepad TXT files on your desktop. That's fine. We have to test it to make sure that we can actually import the data. We have to plan for what the deployment is going to be, because we don't use our production system or our testing system. Maybe we need to redeploy this, and we need to have a proper solution for how to deploy it. And then finally, it has to go into production. Simple, right? OK, so we have the requirements document. So let's start building a prototype for this thing. It starts with brainstorming and prototypes. So an example of the solution without design, if we didn't have that conversation and get feedback, our solution probably would look something like this, right? We'd have a single backend, single Hiera backend, and we would probably use Postgres grants to be able to grant row level or table level access to different people. And then they can go in and hopefully that they know SQL well enough. I don't really know SQL very well, but maybe they can copy and paste some SQL in and then they can change some things. And they only have access because they have the login. And using Postgres' ACL system to handle this. But going back to my slide with the Frank Lloyd Wright House, this is architecture because we have a set schema. We have Postgres as our database. We have a lot of things that are very rigid and we can't swap out for other components. And so I call this the solution without design. So to review our designed solution, this one's a little bit longer. So we have our nodes. Our nodes have a Puppet master, multiple Puppet masters. We have 2 Hiera backends in this case. And so we've designed a filter for the delegated Hiera backend. The filter has, it's designed with a whitelist specifying which keys or namespaces are allowed to be imported from the delegated Hiera database. Our primary Hiera database is still the authoritative. DevOps team controls that. And we have our external data sources in this case. We built simple import plugins, and those import plugins go through a single importer app. And so the importer app handles which keys are coming from which importer plugin. And we've kind of built in this solution kind of like a type and provider analogous to Puppet, where we have these import plugins. All they're doing is reading from external data sources, LDAP, CMDB, REST, Excel file, whatever our abstract external data sources are, and importing them into the Hiera delegated database. In this case, the importer app is just run periodically as a cron. So everyone else has access to all of that stuff, and we know that the things that are being imported are going to be very well controlled. We know that when we query the Hiera database, we can only query through a whitelist of keys. And it solves our delegation problem. So in this one, oops, that didn't come through. So I actually wrote what the implementation, what this actually means, all these different components. Okay, so in this one, what this actually means as far as what the components are, we're using a Postgres database. We have a Python script that just imports stuff. We have CMDBs and LDAP and things like that. And we just have really simple, like 5-line Python scripts that load stuff in through this importer app. All of the primary Hiera database is just YAML files. But what this gets us, as far as our results, is that through this intentional design process of building the prototype, getting feedback, we designed a much better solution that is scalable and extendable. And what we've really done is brought everyone else into the DevOps team. That's when you're supposed to go, ah. Okay, there's a cat for Mike. Go read about some of these things. A lot of these things are maybe things you've already read. Gary has a really good essay about use of Hiera that I really like. The Postgres Hiera backend is really great. And think about good design a little bit. That's it. Thank you.
Questions?
Can I see the last slide again?
Sure. The one with the cat?
That was the question.
That was the question, right?
You want to see the cat, or do you want to see the diagram of everything?
I just wanted the details below it.
Okay. I think the slides will be posted somewhere as well.
Do you know if there's any work to support multiple hybrid backends with the same provider? Because right now we do this, but we have to hack around it by using 2 different providers.
There's a bug for this. It's a 5-digit bug number, so it's relatively new. I think it starts with 13. Yeah, there's a bug for it. You can't right now. Sorry.
Hello. Oh. Thank you for your talk. I like the use of Hiera. I don't like the use of Hiera YAML. And I was wondering if you've seen the securely managing secrets stuff that explains why you shouldn't use Hiera YAML and the workaround.
No, I haven't seen it. What do you not like about it?
The problem with Hiera YAML and those things, they might be good for temporary workarounds and when you're stuck and you used to just store passwords. But the problem is that if you have the private keys and the encrypted bits on the server and your server's pwned, then you have the clear text. Whereas if you even had just like a hashed password, like something from a Kickstart file or whatever, and that's on the server, even that's better than Hiera YAML because you can't produce the clear text directly. So the Hiera stuff is great. I would recommend you check out that work because you might say, hey, this is the new thing.
Cool, thank you.
More questions? Anyone? No more hands?
Thank you, everyone.
Thank you, Robert.
Yeah.